In this video, we want to integrate some functions that we cannot straightly integrate them. Before integrating these functions, first we have to rewrite them in a form that fits with one of the integration rules. As I mentioned before, one of the most important steps in integration is rewriting the integrand. By integrand, I mean the expression in front of the integral, in a form that fits one of the integration rules. For example, here, if you want to integrate x plus 6 over square root of x, we cannot integrate this function straightly with power rule. We have to try to rewrite this fraction in a form that fits with power rule. To do that, we have to separate numerator. By separating numerator, I mean we have to divide each term in numerator by denominator. So x plus 6 over square root of x can be rewritten in the form of x over x to the 1/2. Square root of x is x to the 1/2 plus 6 over x to the 1/2. Now we can simplify x to the 1 by x to the 1/2. We can subtract the powers. Here power is 1, the power in denominator is 1/2. 1 minus 1/2 is 1/2. So x to the 1 over x to the 1/2 equals x to the 1/2 plus 6 x to the negative 1/2. We bring this x to the 1/2 to the top. And to bring it to the top, we change the sign of power. We make it negative. So 6 over x to the 1/2 equals 6x to the negative 1/2. Now we can integrate these expressions with power rule. Integral of x to the 1/2 with power rule equals x to the 3 over 2 over 3 over 2. We add to the power 1/2 plus 1 equals 3 over 2, and we put this power in denominator. Plus 6, 6 is the coefficient. We put the coefficient, we copy the coefficient, and we integrate x to the negative over 1 over 2 with power rule. Negative 1 over 2 plus 1, we add to the power, negative 1 over 2 plus 1 equals 1 over 2. And we put the new power in denominator. So integral of x to the negative 1 over 2 is x to the 1 over 2 over 1 over 2. Now, if we simplify this answer, we can rewrite it as 2 over 3 x to the 3 over 2 plus 12x to the 1 over 2 plus c. Reciprocal of 3 over 2, when we bring this 3 over 2 from bottom to the top, it becomes 2 over 3. Reciprocal of 1 over 2 is 2, multiplied by 6 is 12. If you want, you can rewrite your answer in radical form. X to the 3 over 2 is the square root of x to the 3. 3 is the power, and this 2 in denominator means the square root of the expression. X to the 1 over 2 can be written as a square root of x plus c. We can rewrite a square root of x to the 3 in the form of a square root of x2 times x, and if you pull out x2 from radical, it equals to x times the square root of x. So finally, we can write our answer as 2 over 3 x times the square root of x plus 12 square root of x plus c. It seems that I have forgotten a plus here. There should be a plus between constant c and this expression. So it should be in this form. Let's do another example. Integral of square root of x times x2 minus 1 dx. Again, before integrating this function, we have to simplify it and write it in a form that fits with power rule. First, instead of square root of x, I rewrite it as x to the 1 over 2 times x2 minus 1 dx. Now if I multiply x to the 1 over 2 in the bracket, we have x to the 5 over 2 minus x to the 1 over 2 dx. Note that if you add this power to the 2, 2 plus 1 over 2 is 5 over 2. If you do a simple common denominator between 2 and 1 over 2, it equals 5 over 2. Don't make this mistake that we multiply 1 over 2 by 2. No, when we multiply x to the 1 over 2 by x to the 2, the base are the same, so we have to add the powers. 2 plus 1 over 2 is 5 over 2. Minus 1 times x to the 1 over 2, which is x to the 1 over 2. Now easily we can integrate this expression. Integral of x to the 5 over 2 is x to the 7 over 2 over 7 over 2 minus x to the 3 over 2 over 3 over 2 plus c. We added to these powers 1 and we put the new power in denominator. And if you simplify it, finally the answer is 2 over 7 x to the 7 over 2 minus 2 over 3 x to the 3 over 2 plus c. I leave simplifying this answer and writing it in the radical form to yourself. Let's move to the next example. Integral of x to the 2 minus 3 all to the 2 dx. We cannot integrate this expression in this form. First, we have to rewrite x to the 2 minus 3 to the 2 in a form that fits with power rule. To do that, you can use this identity a plus b, a plus minus b to the 2 equal to a to the 2 plus minus 2ab plus b2. Hopefully you know this identity. But if you don't know this identity, I will show you another way that you can rewrite this expression. But for now, let's use this identity and simplify x to the 2 minus 3 to the 2. Note that if I want to compare this with this identity, a is x to the 2, b is 3, and between a and b we have minus. So x2 minus 3 to the 2 based on this identity equals to a, or first term, x2 to the 2, x2 to the 2 minus 2ab minus 2 times x2 times 3, which is this term, minus 2ab. Note that again x2 is a, b is 3, plus b, or second term, to the 2 plus 3 to the 2. If you simplify this expression, it equals to x to the 4 power to the power, multiply them, minus 2 times 3 is 6, x to the 2, and finally 3 to the 2 is 9. So we can rewrite x to the 2 minus 3 to the 2 as x to the 4 minus 6x to the 2 plus 9. And as you can see, now we can integrate each of these terms with power rule and constant rule. Let me show you how you can rewrite this expression in this form without using this identity. Maybe some of you prefer not to memorize this identity. x2 minus 3 to the 2 means x2 minus 3 times x2 minus 3. In general, we know that power 2 means multiply the expression by itself. And so x2 minus 3 to the 2 is x to the 2 minus 3 times x to the 2 minus 3. And so we can multiply the terms in the first bracket in the terms of second bracket with the FOIL method. x2 times x2 is x to the 4 minus 3 times x2 minus 3x2 minus again 3 times x2 minus 3x2, and finally minus 3 times minus 3 plus 9. Negative 3x2 and negative 3x2 is negative 6x2. So it equals to x to the 2, x to the 4 minus 6x to the 2 plus 9. The answers are the same. Now it depends to you which method you prefer. You prefer to multiply the expression by itself, or you prefer to use this identity. Let's back to our integration. X to the 2 minus 3 to the 2 is x to the 4 minus 6x to the 2 plus 9. Now we are integrating term by term. Integral of x to the 4 is x to the 5 over 5 minus 6. Integral of x to the 2 is x to the 3 over 3. We add 1 to the power, it becomes 3, and we put the power in denominator. Plus integral of constant 9 is 9x. Again, let me remind you, derivative of 9x is 9. So integral of 9 is 9x plus c. If you simplify this 3 from bottom with 6 from top, your answer can be written in the form of x to the 5 minus 2x to the 3 plus 9x plus c.